Hello everyone. So today we'll talk about the electrochemistry and we'll do the 15 most important question from the electrochemistry which can come in your exam, and this video is for the PU student and state board student. Okay, so let us first talk about the first question. First question is very important question. It is Daniell cell and describe the construction and working of Daniell cell. Daniell cell is an electrochemical cell which carries out chemical reaction to produce electricity. So Daniell cell is a type of electrochemical cell. So what are electrochemical cells? Electrochemical cells are the cells in which chemical energy because of reaction there is production of the electricity. So in Daniell cell it consists of two parts. First is called as oxidation half, second is called as reduction half. In oxidation half, what you have put? You have put zinc in a zinc sulfate solution, and in reduction half you have put copper in a copper sulfate solution. Both are connected by wire and solution are connected by something called as salt bridge. Now what happen? So when you connect the wire, what you will see, then you switch on, electron move from the anode to the cathode to produce electricity. Okay? So here what happens? Zinc from the rod will start giving out Zn2 plus and it will start releasing 2 electrons. So this process is called as oxidation, and oxidation happens at the anode. So zinc will loses 2 electron to form Zn2 plus and Zn2 plus will come into the solution, and the charge of the anode, always remember, is negative. Okay, next what happen? These electrons will come inside the cathode. This is called as cathode, and copper 2 plus from the solution will go to the, it will accept the 2 electrons which is coming from the zinc, and this copper will go towards the copper rod. As a result, size of copper rod will increase. So this process is called as reduction, and reduction happens at the cathode. Okay, so cathode, what happens? This copper 2 plus will gain 2 electrons to form copper, and remember, because electrons positive charge species is getting attracted towards the copper, it will get positive charge. Okay, next if you want to write oxidation half, you can directly write, because zinc is undergoing oxidation, you can write Zn is converted into Zn2 plus dash, double dash will represent the salt bridge, copper 2 plus is converting to copper. So this is representation of the Daniell cell, and if you calculate the EMF of the cell, the EMF of this cell is 1.1 volts. Question number second is state and illustrate the Faraday's first law of electrolysis. So what is first law of electrolysis? The amount of chemical reaction which occur at any electrode during electrolysis. So how much is the amount of reaction at any electrode during electrolysis by a current is directly proportional to the amount of electricity passed through the electrolyte in aqueous or molten state. So what it means, suppose you are doing a electrolysis of a solution, and if we take example like electrolysis of water. So how much of hydrogen and oxygen gas will release at the electrodes? So it will depend upon how much is the quantity of the electricity you are passing through the solution, and solution can be aqueous. Suppose you can take NaCl in water, or you can take NaCl molten state. Next, the W gram of substance get deposited on passing Q coulomb of electricity. So when you are passing the electricity, so W amount of substance will get deposited on passing electricity, which is Q coulomb. So how much, if you increase the quantity of electricity, the substance getting deposited will also increase. So it is directly proportional, and you can write W is equal to ZIT. Q, we know coulomb is equal to IT. I is the current in amperes and time in second, and Z is a constant called as electrochemical equivalent. Third question is write a label diagram, explain the standard hydrogen electrode, represent it symbolically, and write the reduction reaction at the cathode and what is electrode potential. Okay, so first we talk about what is standard hydrogen electrode. We also call it as SHE. It consists of platinum electrode coated with the platinum black. So what you will see, there is a wire of platinum, and this platinum is coated with the platinum foil, or we call it as platinum black. Next, the electrode is dipped in 1 molar of HCl. So this solution which we have, 1 molar solution of HCl, and pure hydrogen is bubbled through it under pressure of 1 bar. On one side hydrogen is coming, and we have taken it as 1 bar pressure. Now what reaction happen? The platinum electrode dash hydrogen which is at 1 bar, this hydrogen will convert to H plus 1 molar. Okay, so this is a normal reaction. So now what happened during the reduction? Suppose it is connected to some electrode and this is undergoing reduction, then what happens? This hydrogen plus from the acid will gain the electron to form hydrogen gas, then reduction happens. Okay, next, what is the electrode potential you assign to SHE? The electrode potential you assign to SHE is 0 at all the temperatures. So remember, it is a standard reduction potential and its value is 0, and it is used to compare the reduction potential or to find the reduction potential of the other cells. Question number 4 is, in hydrogen oxygen fuel cell, draw diagram mentioning the cathode and anode. What is electrolyte? Write the reaction taking place at each electrode and net cell reaction. So first we see hydrogen and oxygen gas are bubbled through porous carbon electrodes. The electrodes are made up of carbon into aqueous NaOH solution. So NaOH solution will act as a electrolyte. Finally divided platinum, and platinum will act as a catalyst. So then in the electrode, carbon electrode, they have put some platinum which will increase the reaction. If you look at the diagram, what is happening? Hydrogen is bubbled from the left side, oxygen from the right. The electrode of carbon next to hydrogen is anode having negative charge, and electrode of the carbon which is next to the oxygen where oxygen is coming having positive charge is called as cathode, and you have taken aqueous electrolyte of NaOH. So this is the structure of the fuel cell. Next, what happened at the cathode? At the cathode, always remember, reduction happen. So oxygen will combine with the water, and it will, because it is aqueous solution, and it will gain 4 electrons which are coming from the anode to form 4 OH negative. Next, what at the cathode happen? Hydrogen will combine with 4 OH negative from the aqueous electrolyte. It will combine with this, result in formation of 4 H2O, and 4 electrons are released. And then if you add both the reaction, what will happen? 4 OH and electron will get cancelled. Overall reaction, you will get 2 hydrogen plus oxygen, result in formation of 2 H2O. So this is the fuel cell. Question number 5 is, what is molar conductivity and how it is related to the conductivity? Molar conductivity of a solution at any given concentration, it is the conductance of volume V of a solution. Suppose you have taken volume V of a solution and containing 1 mole of electrolyte. You have taken 1 mole of electrolyte, kept between the 2 electrodes. There are 2 electrodes you have kept between the 2 electrodes with area of cross section A and distance of unit length. Okay, so the molar conductivity is nothing but it is a conductance of a solution where 2 electrodes are present at a unit distance and area of cross section is unit. Okay, it is given by the symbol called as lambda m, and lambda m is equal to 1000 into K divided by 1000 into kappa divided by the m. 1000 into kappa is the conductivity and m is the molarity, and if you write their symbol, it's unit, so it becomes Siemens centimeter square per mole. Question number 6 is, E0 of copper is given as 0.34 volts and E0 of zinc is minus 0.76 volts. Daniel cell is obtained by coupling these 2 electrodes. You have to represent the cell symbolically and calculate the EMF of the cell. First, you have to remember higher value, copper has the higher value, so copper will act as a cathode and lower value will always act at the anode. At the cathode, what happen? Reduction, anode, oxidation happen. So if you have to represent the cell, so remember zinc, there is oxidation happen, so you will write zinc will convert into Zn2 plus, double dash represents salt bridge, copper 2 plus will convert into copper. So this is the representation of the cell. And if we talk about the EMF of the cell, so you have to write E cathode minus anode. Cathode is copper, so 0.34 minus of minus 0.76, so it will become 1.1 volts. So always remember, whenever you have the higher value, that will always act as the cathode and lower value will always act as anode. Question number 7 is, define Corrosion law and Faraday's second law of electrolysis. So what is Corrosion law? The limiting molar conductivity of any electrolyte can be represented as the sum of individual contribution of anion and cation. So limiting molar conductivity means when there is infinite dilution, what is the conductivity? That conductivity we call it as limiting molar conductivity of an electrolyte. So that conductivity will be equal to the sum of the conductivity or limiting molar conductivity of the anion and the cation. Suppose you have limiting molar conductivity of NaCl, so that is lambda naught, it will be equal to lambda naught of Na plus lambda naught of Cl negative. Next is Faraday's second law of electrolysis. This says that amount of different substance liberated by same quantity of electricity. Suppose there are 2-3 electrolytic cells are there and you are passing same amount of electricity, then through the electrolytic solution are proportional to their chemical equivalent weight. So the amount is always proportional to their chemical equivalent weight when you will pass same amount of electricity through different electrolytic solution. This is the value of limiting molar conductivity lambda naught m for NH4Cl, NaOH and NaCl are given as 149.74, 248.1 and 126.4 Siemens centimeter square per mole. You have to calculate the limiting molar conductivity of NH4OH. So always remember, you can find this limiting molar conductivity of weak electrolyte using the Corrosion law. Okay, so what you can use, this is weak electrolyte and it consists of ion of NH4 and OH. So you have to find the molar conductivity of NH4 and OH. So what you will take? You will take a strong electrolyte which has the common ion. So first we take NH4Cl, you will add, okay, because it has the common ion of NH4. Okay, second you will add limiting molar conductivity of NaOH because it has common ion OH. Next you do not want the common the ion of Na and Cl, so you will minus by Na and Cl. So you will get, so if you add these two and minus NaCl, you will get the limiting molar conductivity of NH4 and OH negative. So you will add, so this value is 149.74 plus 248.1 minus of 126.4 and the final answer will be 271.44 Siemens centimeter square per mole. Question number 9 is, what are anode and cathode of lead acid battery? What is the electrolyte? And write the reaction place at the anode, at the cathode and overall reaction during the discharging. So first we talk about the lead acid battery. In lead acid battery, remember, lead will act as a anode and lead packed with the lead oxide means PbO2 result in formation of cathode, and electrolyte you will use 38% of sulfuric acid. Okay, so in the reaction what happened at the anode, lead react with the sulfate ion result in formation of PbSO4 lead sulfate plus 2 electrons, whereas at the cathode PbO2 plus sulfate plus H plus result in formation of lead sulfate plus 2H2O. Okay, and if you write the overall reaction, in overall reaction what happened, Pb plus PbO2 result in presence of H2SO4 result in formation of PbSO4 and 2H2O. So this is the overall reaction. So whenever you have a lead acid battery and it is discharging, this will be formed. And if they asked you what happened during the charging of the battery, so during the charging of the battery, reverse reaction happen. So PbSO4 will convert into Pb and PbSO4 at the cathode convert into PbO2, and this type of battery where we can discharge and we again charge, this is called as secondary battery. 10th question is, calculate EMF of the cell in which the following reaction take place. Okay, so they have given nickel plus 2 Ag plus result and concentration of Ag is given as 0.002 molars. Result in formation of nickel 2 plus concentration is 0.16 molars and 2 Ag solid, and E naught of the cell is given as 1.05 volts. Remember, E naught is standard potential of the cell when both concentration is 1 molars. But here if you look at the concentration, it is not 1 molar, so then you have to use the Nernst equation. So when concentration is not equal to 1, Nernst equation is E of the cell is equal to E naught of the cell minus of 0.059 by N. N is how much of electron is exchanged, and log of Q. Q is the reaction quotient, or also you can write log of reactant raised to their power multiply divided by the product raised to their power, you have to multiply. So reactant, if you look at nickel 2 plus Ag square, because stoichiometric coefficient is 2, nickel Ag plus square. Okay, next important point is, for any concentration of solid and liquid, because solid and pure liquid has a concentration which is constant, we can consider it as 1. So for Ag and for nickel solid, this we can ignore. As a result, E of the cell is equal to E naught of the cell already given 1.05 minus 0.059. Now how much exchange of electron is happening? There are 2 electrons. Nickel is giving 2 electrons and 2 silver is accepting the 1 electron. So exchange of electron is 2. Log of the nickel concentration is given 0.16, and whereas silver concentration is 0.002 raised to power 2. Okay, then you can calculate 1.05 minus 0.0295 log of 1.6 2 into 10 is power minus 3 square. So after doing the calculation, answer you will get 0.194 volts. So remember, this is the Nernst equation. So whenever they have given the concentration not equal to 1 molar, so this equation you have to use. Mention any two factor on which conductivity of an electrolytic solution depends or electrolytic conductor depends. So first, if you are taking electrolytic conductor, then it depends upon the nature of the electrolyte. Suppose you have a strong electrolyte, suppose you have strong acid like HCl, so its dissociation is more, so it will conduct more electricity, so its conductivity will be high. Whereas if you have weak electrolyte like acetic acid, so conductivity will be less. Next, on the concentration of the electrolyte, suppose you have concentrated solution or you have aqueous solution. The concentrated solution will have more conductivity because it can produce more ions. And third is temperature. So with difference of the temperature, conductivity changes. If you increase the temperature, dissociation increases as well as conductivity will increase. Question number 12 is the cell in which the following reaction occur: 2Fe3 plus 2I negative result in formation of 2Fe2 plus I2. So ferric ion is converted to ferrous and iodide ion is converted to iodine. Okay. E naught of the cell is given as 0.236 volts at 298 Kelvin. Calculate the Gibbs free energy at the equilibrium constant. First, we will see how many exchange of electron is happening. Ferric ion is converted to ferrous, and total, if you look at the electron difference, it is 1. There are 2 ions, so total it is gaining 2 electrons. Similarly, I negative is converted to I. There are 2 atoms, so it is giving off 2 electrons, so N value is 2. Next, you will write the Gibbs free energy formula. So delta G is equal to minus N Fe naught. Okay, so N value is already given, we have calculated, which is 2. F is called as Faraday constant, which is equal to 96500, and E naught is already given. After using this formula, you get the value of the delta G, which is Gibbs free energy, minus 45548 joules. Then you will find the value of the equilibrium constant. Now for the equilibrium constant, formula is E naught of the cell is equal to 0.059 by N log of K. N value we already calculated, which is 2. E naught of the cell is already given. You substitute the value. You can find log of K is equal to 2 into 0.236 divided by 0.059. Log of K is equal to A. And if the value is given as A, if you take the anti-log will become 10 raised to power A. So equilibrium constant for this reaction will become 10 raised to power 8. Question number 13. What is corrosion? During rusting of iron, write the anodic and the cathodic reaction and give the composition of the rust. First, we talk about what do you mean by corrosion. When a metal is exposed to atmosphere, it is slowly attacked by the constituent of the environment. So whenever a metal is exposed to the environment, it will get reacted towards the constituent of the environment, such as it can react with the acid, atmosphere, air, oxygen, CO2. It can react. As a result, which is slowly lost in the form of its compound. Metal will react and result in formation of some of its compound, and this process in which metal is lost in the form of its compound is called as corrosion. Next, we talk about the rusting. At the rusting at anode, what happen? Suppose you have iron will convert into the ferrous ion. Okay, so iron will convert into ferrous, plus 2 electrons are released, and at the cathode, oxygen will react with H plus 4 electron result in formation of water. So this is the reaction of the rusting at the anode and cathode. Next, Fe2 plus ion, which is coming from the anode, it is further oxidized by atmospheric oxygen to the ferric ion. So ferrous ion will convert to the ferric, which is Fe3 plus. Then in presence of the moisture in the air, what happens? This ferric ion will convert to the hydrated ferric oxide. So this hydrated ferric oxide is called as rust, which is Fe2O3 x H2O. This is called as rust. How long it will take for deposition of 0.2 gram of silver when silver nitrate solution is electrolyzed using 0.5 ampere of current and molar mass of silver is 108. Suppose you have silver in the solution, silver ion, it is present as silver plus. It will gain 1 electron to form silver. Suppose you want to deposit 1 mole of silver, then you require 1 mole of electron, and 1 mole of electron is called as 1 Faraday of electrons, and it is equal to 96500 coulomb. So we can equate 108 gram of silver will deposit when you will use 96500 coulomb of charge. 1 gram you require 96500 divided by 108, and for 0.2 grams of silver deposition you need 96500 into 0.2 divided by 108. So how much coulomb of charge is required for deposition of 0.2 grams is 178.7 coulomb. Okay, now we know Q is equal to IT, charge is equal to IT, and I is the current, T is the time. Current is already given, which is 0.5 ampere. Time you have to find. So 178.7 into is equal to 0.5 into T. So T is equal to 178.7 divided by 0.5. So time will be equal to 357.4 seconds. So this will be the answer. Question 15 is define limiting molar conductivity and draw the graph of molar conductivity of the KCl and acetic acid. First, what is limiting molar conductivity? It is the molar conductivity of a solution when concentration approaches zero or molar conductivity at infinite dilution. Suppose you are adding water in a solution. As a result, what happen? Concentration decreases, and sometime what can happen, if you have added large amount of water, concentration can become equal to zero. At that moment, molar conductivity is called as limiting molar conductivity. So this is a graph of, this is molar conductivity and this is the under root of the concentration. Suppose you have KCl. What you are doing, you are adding water which is already a strong electrolyte KCl. So molar conductivity is already high. When you add water at infinite dilution, it comes to this point. This is called as lambda naught m, which is limiting molar conductivity. But for weak electrolyte, remember the molar conductivity is very low. But when it approaches almost zero or it is near the infinite dilution, suddenly molar conductivity will increase. So this is the graph for the strong and the weak electrolyte for the molar conductivity. So these were the important questions from the electrochemistry. I hope you understood all the questions. Please like the video. If you have any doubt, write in the comment section. See you in the next class. Bye.